Okay, so we are going to live and, well, we're not going to die by the schedule. We're going to live by the schedule here in Learning Suite. Okay, so today we are covering Chapter 6 and Chapter 7, and I've given you some lecture slides, which these may be this is like one of only 2 days where we have slides. So you've got slides there, you can, so this stuff, you've got access to the stuff that we're going to talk about today. So let me go ahead and present this. I have moved around the point at which I introduced the idea of a variable in this class. And I finally decided it just makes my life easier if I do it right at the beginning of the semester. Even though it's one more day before we really do something really powerful here in this class. It's kind of another day to sit back and it feels like a normal lecture class. But I promise the great stuff is coming. It's coming Wednesday. We're going to be great things in class on Wednesday. But understanding this idea of a variable is important and foundational. And so let's go ahead and dive in. Here we have a computer. So our book is guilty of this, as is most books on programming. This idea of a variable is it's like fundamental to every programming language. Conceivably, there could be a programming language that doesn't have the idea of a variable. I'm not sure what you would do with it. So this is like a common idea everywhere in all programming languages. And almost every place I've seen it talked about, we explain it to you using some kind of metaphor. And while the metaphor of a variable, a metaphor like you think of a variable as a box with a name on it that you can use to put a value in and take the value out. And while that might get you going using variables, it will not serve you well unless you really grasp what's happening with a variable. We're going to do some things with variables in this class that if you're kind of living with this metaphorical understanding, it will blow your mind why they behave the way that they do. So I'm going to teach you today what they really are. The ad drop deadline is when? Yeah, I don't want. This is one of the reasons I didn't used to have this already in the class. I don't want this discussion to scare anyone away. It's going to be pretty technical, but I'm going to tell you which parts of this I'm going to expect you to be able to give back to me at some point like in an exam in the Senate. We're going to go a lot deeper than I'm going to expect you to recall because I want you to have kind of a sense for it, to have the background, even though you might not have it so well that you could like teach this to your mother. I could teach this to my mother. She wouldn't understand it when I was done. She would nod and smile and say, "Dear, that's really nice." But a variable is actually, it's a hybrid construct. It's an idea that is partially based in a hardware. And so there's one place in the hardware of a computer where I can store a value and pull it back readily. Well, there's several places I can store a value. Come up with it. What do we call the places that we can store a value in a computer? It's a hard drive. It's stable storage. You lose power, and whatever's on the hard drive stays. What's another place? RAM. So we've got RAM, like a volatile memory, right? I have power to it for being able to keep its memory. Now, there's one more kind of, even if it's a hierarchy, there's stable storage, volatile memory. There's even one that's even higher. Do you know what it's called? I wouldn't expect you to know this. There's probably someone who knows what it's called. Okay, there's maybe two more. There's cache, which is a little bit of memory that's right next to the processor, and then there's even a tiny amount that's built into the processor called the registry. Yeah, and so there's kind of all these different levels. And so when we're talking about RAM, when we're going to take a value and store it in that volatile memory, we're creating a variable. So a variable is, well, I think I talked about it right on the next slide. Oh, that's what it looks like. There's a memory chip. Okay. So a variable is a location in memory with a name. That's it. It's a named location in memory. So the whole idea behind memory is that I can put a value there, and it will sit around until I want it. And then I can ask it back, what was that value? I don't need that value for a little while, set it aside, and then when I need that value again, give it back to me. That's what a variable is. Now, let's kind of pull out the rest of this definition. Location in memory with a name where a value of a particular data type, we'll talk about data types, then can be stored and retrieved. So that's the idea. Putting data into memory and bringing it back. Now, I guess most of you understand that everything that I put into memory has to be stored ultimately as what? A series of ones and zeros. Everything's got to be binary. I've got essentially the ability to flip and switch back and forth. So everything that we store in there ultimately has to get written down into ones and zeros. And so that's what we're going to be dealing with. Now, it turns out in Visual Basic for applications, we don't have to think at the 1 and 0 level. But if you understand, or at least have some sense for what's happening with the 1s and 0s, the behavior of these variables is going to make a little more sense. And the error messages that you see when you make a mistake in your code, the error message will make a little more sense as well. So even though the lowest level of memory that's addressable is a bit, for binary digit, so one place, 1 or 0, the lowest that we will ever address in VBA is a set of 8 bits at a time. We call that a byte. I don't know why it's called byte. Probably the reason why it's called byte, I don't know. And so the lowest, we'll work in increments of 8 bits at a time or a byte. And so if we have these 8 bits, and I want to store a number, how do I do it? Everything down into binary notation. And so right here, if I have these 8 bits, then each one of these has a value. Here's my 1s column, my 2s column, my 4s column. And so I can put either a 1 or a 0 in each one of these places. And so right now, with this whole thing full of zeros, this is 1 byte. What number is represented here? 0, yeah. You know, there's 1, 2. What does 3 look like? Yeah, it's a 2 and a 1. So all I do is I think about this. I say, all right, you know, I take my 2's column, I multiply the 2 by whatever number is below it, and then it's like a sum product. You know, sum product. You're just doing a sum product here of the set of 1s and 0s, and then the place value across the top, and you get the value. What was it? It's a computer. There's not that many good computer science jokes. It's a pretty good one. It says there are exactly, it shows this number, this number of different kinds of people in the world. Those that understand binary and those that don't. Right? So, because what is this number? Say in binary notation, what is that number? It's 2. Yeah, so when concept goes, they read it, there's exactly 10 kinds of people in the world. Those that understand binary and don't. And they go, huh? You know what kind they are, right? Okay, so 3, 4, what's this one? Yeah, 65. So it's, you know, 164 and a 1. What's this one? Yeah, it's amazing when someone can do that so fast. How'd you do that so fast? Because you got to take 128 plus 64 plus 32 plus 16. How'd you do it? You just added it all up that fast. Are you like working ahead on the slides? No? What's the shortcut to this? Yeah, it's the next one in the series minus 1. What's the next one in these series? Yeah, 256. So everything out to the right is just 1 less than I could get to that next one. So there's 255. Okay, incidentally, let me go ahead and bring up Excel here. Alt F11. Oh, hey, this is still left over from day 1. Very good. Let me go ahead and put, reminds me, I didn't post this. I usually like to post the example from class. I forgot to do it. We'll post it. Sub, I'll call this var1, variable demo 1. Okay, so let me just show you how, so what we're looking at here is we're looking at the simplest kind of numeric data type. And the whole reason that we have a data type, now, when we're actually putting information into memory, all the ones are 0. And so I look at this 8 bytes, this 8 bits, another 8 bits, another 8 bits, it's just 1s and 0s. So you have to have something to say, how do I interpret those 1s and 0s? And that's what the purpose of the data type is. So for the data type, we say, all right, here's this amount of memory, in this case, 1 byte, and I got to know what type it is so that when the interpreter goes and gets that information, go, okay, I've got these 1s and 0s, but how do I interpret those 1s and 0s? And the answer is the data type will tell us. And so one data type that we have here is called a byte. And so we're looking at a byte here. So let me just show you how we actually implement this in VBA. So I'm just going to declare a variable, dim. I will call it, how about salary? This would be a pretty grim salary. As byte. And so this then tells when the interpreter processes this line, it says to the operating system, I need some memory. And the operating system says, great, here's some memory. In fact, the interpreter is going to say, I need 1 byte of memory. The operating system says, great, here's 1 byte of memory. And it's going to give it to my application and going to make sure that no one else has access to it. So, in fact, if a Windows and Mac OS both will terminate the program immediately. Just say, you are done. No warning or anything, done. Why? The way programs work with the operating system says, I'm going to need some memory to do my work here. The program asks the operating system to allocate some memory. Hey, give me some memory. The operating system says, hey, here's some memory, it's yours. And so what's going on if a program tries to access memory that hasn't been allocated to it? What is going on? Yeah, nothing good is going on. Either someone wrote a really bad program by mistake or on purpose, but there's no good reason to let that program run, and your operating system will just terminate the program when that happens. It's done. And so this idea of working with the operating system, hey, give me some memory, it allocates the memory back, and then the interpreter here is going to bind this, the variable name, onto that location in memory. And so now, I don't know which of all the bytes I have working with. All I know is I've got one byte somewhere, and I'm going to refer to a byte saying salary. And so I can say salary equals some value, later on print off salary to someone with that value. Now, in these examples, we're going to be talking about just 1 byte versus 2 bytes versus 4 bytes. But how many bytes do you have in your computer? How many gigabytes of memory do you have? You know? You don't even know. Does anyone know their computer? How much you got? 16 gigabytes. Anyone have more than 16? That's kind of a lot for a laptop. Kind of the current top end. Congratulations, you have the top end. Okay, so that's 16 gigabytes. The truth is, you don't even really know what that means. It's a bunch of ones and zeros. Let me give you a sense for how much it is. The full text of the Book of Mormon is just under 1.5 megabytes. So you've got 16 billion bytes, and in about 1.5 million, you can fit the whole Book of Mormon. And so what does that mean? In your computer, you can fit the whole Book of Mormon something like 11,000 times the full text. So if you took like a little missionary copy of the Book of Mormon and you put it on the floor, and you put another one on top of it, and another one on top of it, so you were representing all the memory you had, how tall? Roughly the height of the Empire State Building. That's how much data you can put in the memory. How much do you have? 4. You can do a quarter of that, but he can do, so you can get up to like, the 27th floor or something. But I don't know how tall is the Empire State Building. How many stories? Probably 100, 120. Anyway, so it really is a lot. So we're going to be talking about the difference between, well, should I allocate 1 byte or 2? Does it matter? You've got billions of these. Does it matter? Not we're only doing 1 or 2 variables at a time, but I'm going to show you later in the semester how to declare thousands or tens of thousands of variables with one statement. And so then it will start to make a difference. But if you're just doing individual variables, which type you use in terms of how much memory you're using isn't really a big deal. And so in this case, I've allocated just one byte. It's just exactly the picture that we have here. And so I can say salary equals 255. That should be the biggest number I can put in there. That should be okay. And then I am going to do a print. Now you remember debug.print. We talked about kind of some of the foundational things we talked about last time we were together. We said that VBA is a blank-oriented language. And what's the word I left out? Object, yeah. So we're going to deal with objects. Objects have 2 characteristics that are critically important to us. They are called a value that describes how the object is, and the other is called a method, and it's an action that the object knows how to do. Okay. So we haven't seen this one before, but here's an object. It's called debug. It's just an object you use while you are debugging. Are you familiar with the term debugging? You know where it comes from? You probably don't know this. In the old days, around this time, when computers took up the size of the rooms. In fact, this one happened to be a particular computer called the ENIAC. It was probably probably as big or larger than this room, a single computer. We programmed it not by typing out a terminal, but by plugging wires into magnetic relays. Plug a wire here, plug a wire here, plug a wire here, plug a wire here. And these switches I open and close when the current's flowing through them to do various calculations. This computer, this huge computer, could do only one thing. You know what it was? Calculate missile trajectories. That's all it did. So we plug these wires around and we say, okay, that's the weight of the payload. We plug it around, and this is the angle, and this is the amount of force. Where's that thing going to hit? That's what this computer would calculate. And so, we're plugging this in. Where will this thing hit? What would happen if we launched a missile from Paris, going this way? What would it hit? And it's coming back and saying it's going to hit somewhere in China. And we know it's not going to hit in China. We know it can't go that way. So we had to figure out what was wrong. Check all the wires look good. And then finally they went and said, well, there must be some hardware problem with the switches, with the magnetic relays that are opening and closing the calculations. And in fact, a moth had gotten into one of these relays. So when the magnet told that relay to close, it didn't complete the circuit because there was a bug in the program. That's the source of that term. And so when we talk about debugging, it just means an error in the program, but it's not a real bug, hopefully. I mean, you could have lights, I guess, in your computer causing problems, but anyway, so there's this object called debug. It's just, that just helps us when we're debugging. It doesn't have very many tools. In fact, debug.print is the only thing I've ever done with it. It has something called assert. I don't even know what that does, but there's another method. Okay, so this should say we're declaring a variable, allocate some memory. When this line gets processed, VBA says to the interpreter, which is the VBA interpreter, says to the operating system, I need some memory. How much is it asking for? You have 1 byte. Because it says byte, that's the data type. And it knows that the byte's data type is just 1 byte. Operating system says, great, here's some memory. Out of all those 16 billion bytes, you get this one. That's yours. By the way, next time I run the program, is it going to be the same one? No, the chances of it being the same one is roughly 16 billion to 1. Well, it's probably not quite that bad, but the point is I don't care physically where it is, just that I've got some memory to work with. And so when I say salary equals 255, this is called an assignment statement. This is not like an assertion of equality. This is me telling the interpreter to make this statement become true. So I'm taking the value 255 and I'm putting it into the variable salary. Whenever I have an assignment statement, I take whatever's on the right-hand side and put it into whatever is on the left-hand side. Now you're used to the idea of equality being reflexive, that you could flip this thing around. Could I flip this thing around and have it mean the same thing? No, because I'd be trying to take salary and put it into 255. That doesn't make sense to it. But taking 255 and putting it into salary, that makes sense. In fact, there's kind of an interesting syntax. It's like an older syntax from the early days of BASIC that's kind of still around here. And you can put the keyword let in front of that, which turns it into a sentence. It actually kind of sounds like the voice of God, doesn't it? Let salary equal 255. It's valid syntax, but we got tired of typing let all the time. And so I said, okay, listen, you don't have to put let. But if you do put it in there, then it reads like an English sentence. Let salary equal 255. So it works either with or without it. And so that puts the value 255 into that location in memory. Later, when I want to see what's there, I just say debug.print what? What do you think I'm going to put here? Yeah, salary. And so now, this is going to allocate some memory. It's going to put a value in that location in memory. It's going to tell me to print what's in that location in memory. And so when I run this, it should print 255. Now, 255, oh, by the way, debug.print just writes out to the immediate window. So we did some stuff with the immediate window last time we were together. If I want to kind of connect up the immediate window for my code, debug.print just sends the value down. All right. Can I record 256? Can I put 256 into this variable? I could squeeze a 2 in there somewhere. Well, this file is full. It's completely full. So this is one. Have you ever had it full all the way to the top? And what would happen if you had that water bottle full all the way to the top and you tried to put more in it? What would happen? It would overflow. Watch this. I'm going to try to put something. This is full. I'm going to try to put a little bit more in. What's that little bit more look like? 256. I'm going to try to run this. I think I'm going to try to run this. Run. Oh, can you see that from where you're sitting? Windows plus. It would have overflowed, and so the interpreter said, I'm not gonna do that. And could you imagine if it actually overflowed? You'd like pick up your computer, turn it sideways, all these bits would come out. So it doesn't actually overflow, thank goodness, but it's saying it would overflow if it would let it. So and so that's the error. You get that error, you don't really understand what's going on with the memory, you get overflow, and you go, I have no idea what that means. But now you know. It means I tried to put more into that slot of memory than it could hold. Okay. By the way, what happens if I try to, so what's the range? What's the range for this data type, for the byte data type? What's the possible range I can put into it? Yeah, 0 to 255. If I try to put more, there's just no room. If I try to put less, what if I try to put like -1? If we debug would be okay. So the lowest is 0, 0 should be fine. If I put a -1, what am I gonna get? Underflow, yeah? No, actually, it's still an overflow, which doesn't quite go with what I was trying to explain, but overflow just means you tried to put something there that didn't fit. And -1 doesn't fit for a similar reason that 256 doesn't fit, but anyway, this isn't going. Okay, so if I want to do more than 256, I need more bytes. And so now I've got 2 bytes. And so this is how I represent 256, yeah? So it's just in my 256 spot, I've got 1, everything else is 0. So, oh boy, what is that? 512, 256. The only reason I know what this is because I've seen this slide before. That should be 1,000. So that's how 1,000 gets stored. Okay, so we've talked about the data type byte. This is one I will expect you to be familiar with. We're going to be a midterm exam. Part of the midterm exam is a chance to compel you to study things you wouldn't otherwise study. And the truth is, you'll get better at this if you have some, at least a general sense, about the different variable types and what their limits are. And so this is one of the things I'm going to compel you to study, even though you would probably prefer not to do it, and that is you'll know what a byte is. What are you going to know about the byte data type? You're going to know that it takes how much memory? 1 byte. That's the easiest one, actually. It can store what kind of values? Numbers, be more specific? No, it stores different ones and zeros. We implement it as ones and zeros, but I store 0 to 255, so you just give me the range, which will give you my next question, but integers, yeah. 2.5 in this? No, integers only. So it's 1 byte, the range is 0 to 255, and it stores integers, and it's called byte. I'm going to commit that to memory. Did you forget it, like right after the midterm? It would be hard to forget. Even if you really tried it, I wouldn't be able to forget. But if you did, but hopefully you'll remember. Okay, there's another data type. It's 2 bytes. It's just like byte. It stores only integers, but it's called integer. So I can declare a variable as byte. I could dim salary as byte, or I could dim salary as integer. Yeah, it's just another data type. And so when I say dim salary as integer, the VBA interpreter is going to ask the operating system, I need some memory. I need it, and how much is it going to ask for? Ask for 2 bytes. And it says, now I've got access to those 2 bytes, and when I say give me information that I put into salary, it'll go back, look at those 2 bytes, look at all those ones and zeros, and because it's data type integer, it will interpret those in a certain way. I could have 2 bytes allocated and have exactly the same ones and zeros, but because it's a different type, it would mean something totally different, and we'll see that here as we go. Okay, but now how about negative value? Can I do a negative value in a byte data type? No, but I can as an integer. So how are we going to do it? Here's the idea. With a byte, I have some representation of an absolute number, 0 to 55, and I add that number to 0. So it's almost like I'm adding it. But for an integer, I have some absolute representation of a number, and I add it to, not 0, but just like -32,000. Do you have to memorize that number? No. But that's where it is. So I'm going to represent some number, and I'm going to say take that number in memory and add it on to this really negative starting point, and that's how I can end up with both negative and positive numbers. And so here I have the value of 1,000 stored, but it's going to get added on to negative 32,768. And so what is going to be the value that's stored here in this data type, in this representation of an integer? Should be negative 31,768. Right? Because it starts counting way down here and then counts forward. And so here is, this is 32,767 represented. And so if I add that to that negative number, I get negative 1. This is how negative 1 looks. So what is this? So the value stored here is 32,768. But what's the number that's going to come back when I say, hey, what's this number? Yep, this will be 0 because it starts counting way down there and then comes up to here. So it's interesting that now when I have just 1 there, that's 0. And so I can just almost ignore that one and say, now it's just the rest of these numbers, right? So if I don't look at this number at all, just kind of ignore it, the rest of this adds up to 33,768. I'm sorry. That's the total amount there. It starts counting at the bottom, and it ends up now at a positive 1,000. If I was to go back and look at my other representation that was, just 1,000, it would look pretty similar, just the difference being right here. Because this bit kind of acts this way, it's sometimes referred to as the sign bit. This is one bit here that says, if it's there, it's going to be a positive number. If it's not there, it's going to be a negative number or 0. Is what's going and that then is, 65,000 is the raw number stored, but it starts counting at negative 32,000. And so that gets us to the upper boundary of this data. So, what do I want to know for integer? You know it takes 2 bytes. It stores what kind of data? Integers. That was easy because the data type says it. And what do I expect to know for the range? So you're giving me more significant digits than you need to. Plus or minus 30,000. Just kind of get in the ballpark on that, right? I'm going to get all the way down to those numbers. But if I've got to store something that goes up to 50,000, is this going to do it? No, it only goes to 30,000. Now, so I've got 1, 2, 3, 4, 5 digits. Can I do zip codes? If I only care about like the northeast part of the country, where I have zip codes that start with 3 and below, could I do 84602? That's right. I got a whole zip code for the university. Our own zip code. Can I store 84602 in this? No, because that's 84,000. It doesn't fit here. So again, plus or minus 30,000. I have that sense. Okay, so there's data type integer. There's the range, and so forth. Okay, there's yet one more type of integer value. It's called long. It's short for long integer. Kind of funny that long could be short for anything, but it is. And so it's 4 bytes, but it all works exactly the same as you've seen in integer. And so, it's roughly plus or minus 2 billion. You don't have numbers that we have to deal with bigger than 2 billion? A long integer, 4 bytes of memory, it's for only integers, and it's roughly plus or minus 2 billion. Okay, so now how about decimals? Because decimals are kind of important. So there's a couple of different options. Go ahead.
With the negative number, is that just the way that the VBA interprets it? Or, I guess, how do you represent a negative number in just 1 and 0?
So the question is, how does this whole negative thing happening here? How do you represent a negative numbers in just 1s and 0s? And the answer, you really don't, because you have 2 symbols, a 1 and a 0. There's no negative sign that you can use to do this. And so the whole idea here with a long integer is that we do the same thing. With our 1s and 0s, we represent some absolute value here. And then instead of saying that's my number, I say now add that onto my starting point, which here is negative 2 billion, whatever that number is. And so that's the whole reason the data type is important, is because I've got here just a set of 1s and 0s, And when the VBA interpreter goes to memory and says, I want to see what those ones and zeros are, it needs to be able to say, ah, I see what those ones and zeros add up to, but I know that this is a long integer. And so I have to take that numeric representation, that's just the ones and zeros, and add it onto my starting point to figure out what's the real number that the user is storing here. So if it's less than 2,147,483,000, if it's less than that, the number is going to be negative. If it's more than that, it'll be a positive number.
So does it use 8 bytes, I guess? Like, or does it just know the number?
Oh, yeah. So the question is, where does this come from? Where does this starting point come from? And the answer is VBA knows that. So VBA, when I create a variable of type long, VBA goes, long, I got this figured out. It starts at negative 2,147,000,000. So that's built into the language. And other languages will implement these variables differently. This is just, in terms, they might have a different starting point. They might have a different amount of, they could have some kind of integer type that takes 6 decimal or 6 bytes. The biggest one that we have is 4 bytes. So we have to do some kind of little magic to be able to handle positive and negative numbers, because as you so astutely pointed out, with ones and zeros, there's no such thing as negative. And so, but negative is important. So we've got to figure out a way to do that, and that's how it's done. Okay, so the next thing that's kind of important, again, with ones and zeros, are there any decimal points? There's not. In fact, there's only 2 symbols, ones and zeros. So how do we get to decimals? There's a couple of different approaches. One is what we call a fixed point number. We say, listen, we're just a particular number, and we always know that that is stored to 4 decimal points of precision. So the data types that we have, there's only one fixed data type, fixed point data type, and it's, I think it's 4 bytes. But let's look at this one. So here we've got this number, 65,535. And then what we're saying is just move the decimal point over 4. And so that's like saying, because we always, whatever number we store, we always store to 4 decimal points of precision, then we just know whatever number is stored there. Move the decimal point over by 4, same thing as divided by 10,000, and that's going to give me then just numeric value. What if I want to store just 6? No decimals at all. What do I store? I put 60,000 as a number, and then the decimal point gets moved here, and I have 6. And so in a fixed point, we just say, every number we always store, it's like a negative number. It's always going to start from this negativity and move forward. Here, we're always going to have 4 decimal points of precision. The data type that we have for that, here's another one, another example, is called currency. So it's 8 bytes. This one can handle the natural data for now. Once our data gets to quadrillion, we'll have to think of it. Let's see. Yeah, trillion, so billion, trillion. So what do I expect you to know for currency? Yeah, big numbers, positive or minus, and it's always, it's always 4 decimal points of precision. Do you have to know 922 trillion plus or minus? No, not really. Just big numbers. Is it billion? Yeah. Oh yeah, 100,000s. Yeah, you're right. We can't even do, darn it, we can't even do our national debt here. Thank you, 922 billion. How does it represent decimal value? So there's option 2, and that is, instead of saying it's always to a certain amount of precision, we could say, listen, just use, again, my ones and zeros, let's start a number, and then we'll say, with another part of that memory, store where the decimal point goes. So we'll allocate part of the memory just to say, where does the decimal point go? And then the rest of it gives me the base number to work with. And so there's no floating, this is called a floating point number, because the idea is I store an integer, and then the point just kind of goes wherever I tell it to go. The smallest floating point number we have is 4 bytes. We're doing this demonstration with 2 bytes just so it's a little easier to see. And so we have, here I've said I'm going to allocate these 4 bytes, or these 4 bits, just to tell me where the decimal point goes. And so here I've recorded the value 3,574, and because the location of the decimal point is 0, then that's it, that's just a number. But if I say it's got one decimal, it's got one, the decimal point goes one from the right, now that's 357.4. Or if I say it's two from the right, it's 35.74. Or three from the right, it's 3.574. So part of this says, up here, it says, oh, we're going to say this has 3 decimal points of precision. And then the rest of the number here is stored. It's called a floating point number. And again, it's kind of a basic kind of data type that we have in virtually every computer programming environment. So floating point numbers are important. That's what it would be if I had all those numbers that way. There are 2 data types for floating point numbers. One's called single. Stands for single precision floating point number. It's 4 bytes, and then there's that could handle our national debt. And then there's double, which is 8 bytes, plus or minus that. But the issue here is that these numbers only have a certain amount of significant digits. We saw how we could push that decimal point all the way past my numbers. It's kind of the same thing that's happening here. So I've got, we are significant to 15 digits, but it can go really, really, really big. Now, the truth is, I showed you kind of a simplified version of how the floating point number is implemented. I'll be fine for what we do in this class. The disclaimer is, in VBA, it's a little bit more complex than that, but I want to get the idea. We have some part that stores the number, some part that stores where the decimal point goes, and then working together, we can come up with a number. Okay, questions then on the floating point numbers? We got to work with dates. Good heavens, how do we get from ones and zeros to a date? This is the kind of thing that computer nerds ask themselves all the time. How can I convert all these ones and zeros into a date? I don't know. So here's what we do. We store, again, the only thing we can store as ones and zeros is we can store a number. So what do we do with that number to get to a particular date? And the answer is we take that number and we add it to some starting point. And so the starting point in VBA is weird. It's December 30th, 1899. What's so special about December 30th, 1899? No computers. No computers. Actually, I think this was initially an error. I think they probably meant this to be January 1st, 1900. They missed it by only 2 days. And in the original implementation of Excel, there was actually a bug in the way the date was calculated. And I think we're actually seeing something going here. So that is now officially the starting time for a date. So we store a certain number of days, and then we say, all right, just count up from December 30th, 1899, however many days that is, and that's our new date. And so, imagine that we've got these 2 bytes, 27,000. And so we add to that initial date, we then add that number of days, and we come up with the 4th of July, 1776. I had to pick some date, and so you see that's why I chose that.
If the sign bit was 1,
The question is, if the sign bit was 1, would I go the other way? And the answer is yes. And so we have kind of the same thing where we're storing a number, and it can be a positive or negative number depending on how the sign bit is set. And so we can go, the good news is we can go before 1899, December 1899. So, okay, so that's how it is a date. How about a date and time? Yeah, a decimal, so that's a number of days plus a decimal fraction of how far into the day that we're talking about. So instead of just storing a whole number here, we can store a part of a number. And so now we get 9 o'clock a.m. on July 4th, 1976. Questions? And so dates then, so the date really is, it's just it's like the long data type. It's 8 bytes, floating point number, but it means something different if VBA knows this is a date type versus if it's a long type. But you see, it's exactly, it's 8 bytes, evaluates to the same kind of number, but then it's plus or minus depending on the data type. So VBA knows when I declared this variable, it's a date. So when I pull it back, it first figures out the number, and then it adds it on to December 30th, 1899, and it says, aha, this is the date. Go ahead. So what you're saying is that there's still issues in Excel with dates around the turn of the 1900s.
Yeah, so like does VBA not worry about that then?
Yeah, so the question is there some kind of error dealing with dates earlier than 1900? And the answer is no, we're just fine in VBA. So I could end this. So let's just go ahead and try to do it. Let's go ahead and declare salary as a byte. Let's declare birthday as date. That birthday, I bet someone can guess the number I'm going for here. It has to be before 1900. Guess what it is? Come on, with the opening quote, you gotta know where my mind is today. Okay, so yeah, slash for one, dot for the other, that would be really good. And then this is birthday. So if the problem that you're talking about that happens in Excel happens here, this should be a problem. At some point, this should cause us an error, but it'll be just fine. Want to see something interesting? So it turns out there's all kinds of built-in functions for converting between one data type and another. And so here I have a date. We'll talk about the string data type in a minute, which is what I really have here. But I can say print. It's the same as debug.print. I guess I could type the whole thing out. When it's here, it just knows debug.print. Print, and I will say CDBL, convert to double. I guess I gotta make a date first. So it'll be first to a date. CDBL. I'll do it here. I'll print CDBL, and this should give me a floating point number that tells me how many days away it is from so that's negative 45,103 days before December 30th, 1890. Okay. Other questions on the date type? By the way, when is midnight? When is midnight today? Is it coming up or is it already passed? It's already passed. Yeah, midnight. It's kind of a strange thing. Midnight is the very first instant of any day. And oddly enough, it really isn't AM. It's midnight. Just like noon isn't really PM, it's noon. What does PM mean, by the way? What does it stand for? Yeah, it means after the middle. It means afternoon. So noon is afternoon? No, it's noon. There's no AM, there's no PM. Oh, anyway, okay. How about a name? How do we keep track of, we got all these things are the numbers, how do we keep track of Nephi? By the way, let me some time when there are some questions that really bring us possible. I hope you'll remember back to this moment when I used a name from the Book of Mormon. Okay. So how does it do it? Here's how it does it. It says we are going to map a set of numbers to some reference table of characters. And so it's going to say, here we go. Here's 65. 65 is stored. VBA is going to know, aha, 65 means 1. I'm sorry, 65 means capital A. What does 66 mean? Any guesses? Lowercase. Not lowercase. Any guesses? Capital B. 67. Capital C. Yeah. Lowercase actually comes a little bit later. It's up in like the 90s. So that's how it stores it. It just says there's a standard set that converts these numbers that get stored as ones and zeros into characters. By the way, what's that set called? Do we know? Yeah, it's the ASCII set. ASCII. I can't remember what it stands for. American Standard ASC Character Information Interchange or something. Oh, American Standard Code for Information Interchange. Not quite yet. Let me just bring this up. Hopefully it's going to come up. Go bigger. There it is. Control plus. I think I made it too big. There we go. So there is 65. 65 is capital A, just like we said. There's a question over here somewhere?
I was going to make a comment that
Comment?
when you're working on your homework, make sure if your wife are listening to you, your wife is sitting there listening to you, she knows that ASCII is a technical term. Because me and my brother were doing some homework and we had to work with ASCII characters, and our wives were just cracking up because they could not figure out what we were talking about because it just sounded really weird the whole time.
ASCII. Important safety tip. The fact that your wives are listening to your homework is a little bit weird by itself. But clue them in. Might be a good idea. Okay, so I'm just going to take that same and take the same representation. I'm going to turn it sideways, and then we'll add in a few more characters. And so it takes, here 65 is capital A, 100 is lowercase d. Uh-oh, didn't mean to bring up that. Then 97 is lowercase a, 109 lowercase m. Commas have their own. It's just another symbol. Space has its own symbol. It's verse number 32. And so we've got then these 128 is the base set of characters that we work with. Each number maps to, actually, 128. 0 through 127 are the numbers then that we use for these characters. And so it's the same thing. A bunch of ones and zeros are stored because VBA knows it's a string, when it gets those numbers, it goes, but we're not done with the numbers. We go look at the ASCII chart, and we convert those one byte at a time. We convert those into characters, and it will give us back the characters. Questions? So let's just see this one in action real quick. So we've got a birthday going on here. Let me dim name as a string. Name equals Nephi. Oh, interesting here. Let's talk about the quotes while we're here. Debug.print name. So it should now print some number and then print Nephi. So now we've got, did I spell that right? NEPHI, yeah. Okay, but this introduces something else now that I have done so often, I just kind of take it for granted. And that's this double quote right here. Now, when I'm working with like a number, like we have way up here, that is a numeric literal. That's just a number written in the code. That really is just the number 800. Numeric literals don't take any kind of symbol to signify it, because if I have anything that starts with a number, 0 through 9, the only thing it could possibly be in VBA is a numeric literal. That's the only thing that's allowed to start with a number 0 through 9. I'm not even sure that it's 0, maybe just 1 through 9, because leading 0 would get trimmed away. And so I don't have to do anything special to tell it, hey, this is just a value, because it's the only thing it could be. But what about Nephi? What if I didn't have the quotes? Do you see the ambiguity here? What could Nephi be? It could be a variable. It's a valid variable name. It could be an object. It could be another procedure. There are lots of things that it could be. And so, with a number, I just put the number in and go, oh, that's just a number. But with a string literal, I have to tell it, hey, this is not a variable. It's not a procedure. It's not a constant. It's just these characters, NEPHI. It's literally these characters called a string literal. I have to put double quotes around it. And so that's what the double quotes are for. It says to the VBA interpreter, don't try to figure this out. This is not a trick question. It's just these 5 letters, NEPHI. Okay? All right. Oh, I didn't have to go find it online. There's the ASCII chart right there. And there's what it stands for. So, I'm now looking at these. Oh yeah, because it looks funny to me because it's turned sideways from the way I normally think of it. So for a string, we then have 8 bytes of overhead. Take 1 byte per character to be able to get the information that I'm after. And then we have 4 bytes that tell me how long this string is. So here I've represented 11. If you think of it sideways from the way, we have 11 represented here, 8 plus 2 plus 1. And so the first 4 bytes just say this string is 11 characters long. And so when VBA asks for this memory, says, hey, operating system, give me some memory, and it knows it's getting ready to store John Adams, it says, give me 15 bytes of memory. And what does it do with those 15 bytes? In the first 4 bytes, it records 11. And then in the next 11 bytes, it stores the actual characters. 1 byte for each letter that it's storing. Now, you should realize now something is very different compared to all the other data types we've done. And all the other data types, it's a fixed amount of memory, and then we can put up to a certain amount based on the data type, right? So if I've got a byte data type, it's going to be 1 byte. And I'm limited by what I can put into it. String is a variable length data type, which means how much memory is it going to take? It depends. It depends on what I'm going to put into it. And so it's just a little bit different. It has to. All the other data types, the fixed data types, VBA knows it's 4 bytes, it's 2 bytes, it's 8 bytes. Another type, it's 8 bytes. For string, String knows it starts, location in memory is where it starts. Read the next 4 bytes, find out how long it is, and then read that much more memory. And so we have this overhead. So this idea of overhead gets introduced with strings. There you go. Questions here? 4 bytes of memory overhead plus 1 character, 1 byte per character. So what does that mean? If I've got 4 bytes of data, how long could a string be? It's the biggest number I could do with 4 bytes. Well, yeah, for a 4-byte integer, it's plus or minus 2 billion, so it's like 4 billion. Because it's starting, counting way down in the negative numbers to get there. So what's like the longest string I can have? 1 string? Yeah. 4 billion bytes, 4 gigabytes. I get 1 string variable that's 4 gigabytes. That's a lot of characters. I could just dump all that into a string variable. Okay? I'm starting to think that's the end of the presentation. There was one more data type I want to talk about. I'm kind of surprised I didn't put it in the actually there's 2 more I want to talk about. So let's talk about another type as we're just going to look here in VBA. I'm going to introduce both of these quickly, and we'll spend more time on them as we go. Let's talk about kind of the catch-all data type, and that's called variant. If I make a data name here as string, I'll call this as variant. Variant is an interesting data type. And it goes to the fundamental philosophy of what VBA is as a language. And so when the good folks were inventing VBA, they thought, we want this to be a user-friendly language. How many of you have programmed in Lisp? Oh, it's not a very popular language. And would you say that when they were making a list, they thought, we want this to be a user-friendly language? No. It's a crazy language. And it really hurts your head to work in this language. Some languages are really hard to work in. This is a good example. But when we're making VBA, we want this to be easy because we somehow think that ordinary end users are going to be able to use this language. Not the gods that call themselves computer scientists. Normal people be able to use this language. We want it to be pretty easy. So they made variant. They made data type called variant. Variant is a miraculous thing. It behaves however you treat it. You treat it like a string, it behaves like a string. You treat it like a floating point number, it behaves like a floating point number. You treat it like an object variable, as we'll talk about in a minute, it behaves like an object variable. What's the cost for that? There's two costs. The first cost is, how much overhead is there for string data type? $4. How much overhead for variant? 22. Much more. Oh wait, how much memory do you have? 16 billion. Are you concerned about having 22 bytes of overhead? That's more than one variable at a time. 20, 30 variables at a time. You're doing hundreds of thousands of variables, then maybe be worried about it. But here's the other overhead, and it's a much more important overhead. And the answer is because there's some ambiguity about what data it's storing. It's not ambiguous to VBA. VBA knows exactly, it's got a whole set of rules that it says, when you take a string and you add it to an integer and you put it into a variant type, it goes, aha, I know how I'm going to treat it. I know how I'm going to treat that. And it will behave differently depending on the values that are there. But the point is, there's a very complex set of rules about how this data type behaves. It has to infer what you mean by it. And when I say it's ambiguous, it's not ambiguous to the machine. But I don't know anyone who has ever memorized a whole set of rules that happens for variant. It's a pretty substantial set of rules. And so on the one hand, you might think, hey, this is pretty easy. I'll just take out all my data type variant. I'm using an extra 22 bytes per variable. What the heck? I only have to think of one data type. That would actually work okay for you once you get past the midterm. The midterm, you got to know data type. But the problem is you're introducing a whole level of ambiguity. You're not quite sure what's really happening. And so I'm going to encourage you, at least for this class, to say only kind of a couple of times that we'll say variant's the right one to use. And every other time you're going to say, I'm going to pick the right data type to use for this example. Okay, now this next one I'm going to show you, I'm not expecting you to fully grasp it right now. It's a complex thing. I just want to expose it to you. We'll spend more time on it as we go in the semester. And that is an object data type. So make a sub procedure here for a new little example. Sub, I'm going to call it objvar, object variable. Sub, oops, no space, thank you. No underscore either, that's okay. The underscore would be okay, but I deleted it by accident, now it's gone. Dim cell as range. Not call it as range, let's call it as object. I have a particular cell. Think of the cell B2. That's an object. It has methods and properties. Someone tell me a property that cell B2 has. The name of a property. Oh, it's got a font property. One more. Hello. These are weird properties. Someone give me a method of that object. That's easy to work with. We only talk about one, I think. Oh yeah, delete. A column has a delete. A cell itself doesn't have a delete. But it would have like a select or an activate method. So it's an object. It has properties and methods. That object has to be somewhere in memory. It's not these values that we store somewhere. The object itself is in memory somewhere. What an object variable lets me do is it just lets me record the location of where that object is in memory. It actually, it's some location. And I can say, I just want to remember where that object is in memory. And so here's how I do it. So I'm going to refer to range B2. And I'm going to say cell equals B2. I'm not quite there yet. Remember that we're trying to make this language like really user-friendly, really easy to work with. Because of that, if I just refer to an object and don't call the property or method, VBA says for each object, well, for most objects, there's going to be a default property. And if you don't tell me a property, I'm going to assume a property. And guess what it is for like a range? You have to get all the properties, what are the default properties for a range? It's not select, it's a method. It's an action. The default property, just the value. If I just said range B5 equals 6, the interpreter is going to say, oh, you poor programmer. It doesn't make any sense. I said the object equals 6, but I bet you mean the value of that object equals 6, and it would just go. Oh, the value. And it would assume that the value. Because there's this notion of a default property, when it just sees this, it goes, oh, you sorry programmer. You didn't tell me the property. I'm going to assume you mean value. I don't want to do it all. I want to bind this object variable onto this object. In other words, I want the interpreter to tell me, hey, somewhere in memory, this object is sitting at some location in memory. I want to know what that address is so I can put it here into this variable. And so to do that, you remember the shorthand that we had? If I wanted to turn this into a sentence, what word do I put here? Let. Well, when I'm binding an object variable onto an object, I say set. This is just a kind of an unfortunate thing about VBA. Is that when I want to bind an object variable onto an object, I word set. And the philosophy is 99.9% of the time when someone refers to an object by itself, it's some inexperienced programmer who forgot to put the property. I'm going to assume the default property. For that other 1%, where I have a knowledgeable programmer actually doing this complex thing of binding an object variable onto an object, it says, you must really know what you're doing here. So we're going to make you remember the syntax. It's a little bit unusual to do this. And so it says, you advanced programmers that are going to be using object variables, you have to learn to use the keyword set. So what this does is I now have two different ways to get to that location in memory where that object is. Here's one way. Here's an expression right here that would let me refer to that location in memory. This says to the interpreter, go find out where this object is that I've identified by saying range B2. It has to go run some code that says go figure this out. Well, I can now, so I could do this. Let's do this. Let me say range. I'll put this before I bind the variable. I can do it after, but let me put it up here before. Or I can do it this way. Here's another shorthand for working with cells. B2, no quotes necessary. B2 dot value equals 4. And now I'm going to say cell dot value equals 5 or 6. After I run this code, what is the value that's going to be in B2? Yeah, it's gonna be 6. Let me go ahead and run this. Let me put this off to the side. Well, this is me figuring out how tall the Book of Mormon stack would be up to the Empire State Building. Back to B2. I'll do a little trick here. I'm going to run this in such a way that we can see it go step by step. I'll show you how to do this later in life. F8. Okay. So here's going to execute that line. It's going to put 4 right there in B2. I'm going to bind this object variable onto range B2, and that's now another name for that range. It's another way for me to get to that same object in memory. And so that's going to, when it executes that one, it's going to put 6 in that same location. You might wonder, why would I ever do this? And the answer is, at this point, there are good reasons why you might want to do this. But I wanted to introduce this to you because it's another kind of variable. Okay? So this is one we're going to come back to and back to because it's a lot more complex than the other ones. But there's this in this object. Question? Ah, good question. So this right here, the question is this now, does cell refer to range B2 on whichever sheet is active? And the answer is this expression, because I didn't tell it what sheet, it assumes the active sheet. But this goes and finds a particular object in memory. And it's at a different location than the B2 is on any other sheet. And so this is going to be bound to range B2 on sheet 2 because that's what was active when I ran it. If I were to run this code again, but yeah, if a different sheet's active and I say change, let's go ahead and do it. I'm going to set sheet 1. I will go back and run this again. I'll put 67 in there. I'll execute this line. It's not going to change B2 here. Gigs is going to stay the same because it is bound onto the one that was active when the line executed. Okay, another question. So is this just naming, the question is this just naming a cell or a range? And the answer is, you can think of it that way, that would probably be okay, but this this is now it's a variable location in memory, and what it stores in memory is it stores the memory address where that object is located. It doesn't have to be a range. It could be a worksheet. It could be, there's lots of different objects it could be. It could be a part of a pivot table. It could be a chart that I'm binding on to. There are other kinds of objects I haven't even dreamed about yet. So it says, hey, that object's in my memory. I just want a quick way to refer to it. And I'm going to think of it as a nickname for that object. But it's really it's a name for location in memory where I have stored the address of another variable. And so, because it's a different kind of data type, when it asks for that number, it goes, oh, I see the number that's stored there. Because it's an object variable, I know that's a memory address. It goes and looks at that memory address and advances to that, and it actually returns the object that's at that location. More complex. If you went, oh my gosh, I'm so glad the I dropped the deadline tomorrow. Don't talk to class over the object variable. We're spending a lot more time with that. You will get comfortable with it. We can get to chapter 7. Chapter 7 is about operators. So I'm going to quickly kind of look at this. I think mostly you'll pick up as we go, so you might have some questions, but it's like, what does the plus sign do? You got all these kind of arithmetic operators, division, subtraction, modulus, differentiation. There are logical operators, and, or, not, string operators, concatenation. Chapter 7, probably good to kind of look through that. But we'll call it good for there. Thanks for coming. Class dismissed.